All right, let's talk about C. One of the most fundamental and, let's be real, sometimes super frustrating parts of the language is how it handles functions. If you've ever found yourself asking why C is so incredibly picky about the order of your code, well, you've come to the right place. We're going to demystify all of that today.
So you've been there, right? You write this function, it's logical, it's beautiful, but the compiler just throws a fit, all because of where you put it in the file. What's up with that? Well, it all boils down to this one really simple but really strict rule that the compiler lives by.
In that rule, it's all about how it reads your code. See, a compiler isn't like us. It can't just glance over the whole page and get the gist of it. Nope. It has a one-track mind, and it reads in a very specific way.
It reads your code in exactly one direction, from top to bottom. That's it. It's a one-way street, no turning back. So if you try to use a function before the compiler has even been told that function exists, it just gets completely lost. It's like, whoa, what is this thing you're talking about? And boom, that's where you get those errors. But don't worry, there's a really elegant solution to this. And to make this whole thing click, we're going to use an analogy that I think you'll find really helpful. Forget about code for a second, and let's imagine we're at a restaurant. I promise this is going to make the entire structure of a C program make so much more sense.
Okay, so you sit down, and what's the first thing you get? The menu, right? The menu tells you everything that's available. You don't know how the chef is going to make the burger. You haven't seen it yet, but you know it's on offer. You know its name, and you know what it needs from you, your money. So you've looked at the menu. Next up, you place your order. You flag down the waiter and say, "I'll have this special burger, please." You're making a specific request based on what was on the menu, and you're expecting something in return, right? You're expecting that burger to show up at your table. And then, of course, there's the kitchen. This is the magic room, right? It's where all the actual work happens, totally behind the scenes. The chef is in there, grilling, chopping, putting it all together. You don't see any of that chaos. You just get the final, perfectly assembled product delivered to you. Okay, menu, order, kitchen. Simple enough. But how in the world does this connect back to C? Well, it's actually a perfect map for how we should structure our code. Check this out. The menu, that's what we call the function prototype. It's just a declaration telling the compiler what's available. The order, that's your function call. That's the moment in your code where you actually ask for the thing. And the kitchen, that's the function definition. That's the block of code where all the work actually gets done. It's a perfect one-to-one match. Menu, order, kitchen becomes prototype, call, definition. All right, that's the theory. It sounds good, but let's see what this actually looks like in a real C program. Let's get our hands dirty. So here's our menu item, the function prototype. See how it's placed right at the top, even before main starts? It's basically a little promise to the compiler. It's saying, hey compiler, just so you know, later on you're going to see a tool called calculate_area. It needs 2 integers to work, and it's going to give you an integer back. Just trust me on this for now. That's it. That's our menu.
And now we place the order. This happens inside main. When we call calculate area, something really cool happens behind the scenes. First, everything in main just pauses. Then the values you're using, L and W, they get copied over to the function. Next, the program's execution literally jumps away from main and goes to find the function's definition, the kitchen. And once the work is done, a result is sent right back, and main picks up exactly where it left off.
And here it is, the kitchen, the function definition itself. This is the block of code, usually sitting down below main, that has all the step-by-step instructions. It perfectly shows that separation of concerns. The kitchen is separate from the dining room, and the function's detailed logic is separate from the main flow of your program. Okay, so we've got the flow down. But just like any good restaurant, there are a couple of really important rules of the house we need to know about how these different parts talk to each other. Rule number 1, and this is a big one, variables are private property. Think of it like this. Main has its own stuff, its variables L, W, and area. The calculate area function has its own stuff, its private copies length, width, and result. They cannot see each other's variables at all. The only way they communicate is by passing copies of values back and forth. It's like Vegas. What happens in the kitchen stays in the kitchen. Okay, what about the delivery from the kitchen? If a function's menu item says int func, it's promising to deliver an integer. Your main function needs to be ready with a variable to catch that delivery. But if it says void func, that means no delivery. The function might go off and do something, like print to the screen, but it's not sending any value back. You can't try to catch a return value from a void function because there isn't one.
You've probably seen this warning before, right? Implicit declaration of function. What does that even mean? Well, in our restaurant analogy, it's the compiler screaming, "Hey, you just tried to order something that wasn't on the menu." It's telling you that you forgot the prototype. The compiler might try to guess what you meant, but it's basically saying, "This is super risky, and I don't like it." If you see that warning, it's a dead giveaway you're missing your menu.
Okay, let's bring it all home. We're going to wrap this up with a super simple, practical checklist you can literally use every single time you write C code. So here's your mental checklist. Number 1, the prototype. Did I put my menu up above main with a semicolon? Number 2, the call. Did I place my order correctly inside main? Number 3, the definition. Is my kitchen fully built out below main with all the logic inside curly braces? And finally, number 4, isolation. Is my main function just managing the calls, and are my other functions doing all the real work? You nail these 4 things, and you're going to be writing clean, professional, error-free C code. You see, once you get this simple structure, prototype, call, definition, you're not just banging out lines of code anymore. You're actually designing it. You've leveled up from being just a coder to being a software architect. So now that you've got the blueprint, the only question is, what are you going to build?